Triangulation. Triangulation is a way of using trigonometry that allows us to work out a distance or a position of an object where it's hard to measure that distance directly. One way that triangulation is still used is in fire spotting towers. A quick Google tells you that there's around 70 fire spotting towers, for example, used in Victoria during the bushfire season. Yes, someone spends their whole day in a tower looking for fires. But if you just had one tower, all the person can do is call up and say, look, there's a fire to my north. They could give their bearing, but you've got no idea how far away it is. What they do is they have two towers, or several towers, and you'll get a bearing from at least two towers. We know the distance between all the towers. So in this question, you'll see we've got two fire spotting towers, and we know that they're 7 kilometers apart, and we know the bearing between the two because they're on an east-west line. From Tower A, we spot a fire on a bearing of 310 degrees true, and from Tower B, we look at the same fire on a bearing of north 20 degrees east. And we want to know which tower is closest to the fire and the distance that tower is from the fire. So we start by drawing a diagram. Our towers are on an east-west line. Draw an east-west line and position two compass roses where you're going to place your towers. Don't label them A and B yet, because that'll be much easier once you've got your bearings in. So our first bearing is 310 degrees true. Our other bearing is north 20 degrees east. Don't just leap in and decide to draw them, because if I picked the wrong tower to get the wrong bearing, then what I'd get, just quickly drawing it over here, is looking off in two directions like this. Obviously, those towers are not looking at the same fire. So, northeast, north 20 degrees east, is obviously going to have to go from our left-hand fire spotting tower. Put our 20-degree angle in, which means 310 degrees true obviously goes from our right-hand tower. You'll find that drawing a diagram to give us the overall picture and then drawing a separate triangle is a good idea. Now remember that our bearings are just that, they're directions, and we should label what that direction was at the end of that line. Remember, bearings are not angles, they are directions, but they give us useful angles at the compass rose. So I've got a lot of useful information here because I've got an east-west line. We can label our fire towers. Tower A had the 310 degrees, and that's Tower B on our left. So because I've got a northeast 90-degree angle with 20 degrees, I'll have 70 degrees on this corner of the triangle. I've got 310 degrees around. Now that's 270 from north around to west, so I'll have 40 degrees inside the triangle there. And if I have two angles of a triangle, of course I can subtract them from 180. So I've got 70 degrees in my remaining corner. And of course I have a distance of 7 kilometers from Tower A to Tower B. At this point, it's a really good idea to redraw your triangle because my diagram has got somewhat messy. A very inaccurate drawing of mine there, since if these two angles are the same, I've got an isosceles triangle. Now, it wants to know which tower is closest to the fire. We do not have to find both sides to know this answer. The shortest side of a triangle is opposite its smallest angle. So we have two angles of 70 degrees and one of 40 degrees. Side A, opposite angle A, is the shortest side, and thus it's closest to the fire. So we've answered the first question immediately. Label our sides A, B, and C. We've labeled our extra point where the fire is, C. And you'll see that we have a pair of side and matching opposite angle, and we need to find a side. That says we're using the sine rule, and we're using the sine rule to find a side. So it's A over sine A equals C over sine C. Substitute your values in. A over sine of 40 degrees is 7 over sine of 70 degrees. Rearrange. A equals 7 sine of 40 degrees over sine of 70 degrees. And grab our trusty calculator. Double check that we are in degrees mode. Remember, every time you reset the memory, these go back to radians. And we want 7 sine of 40 degrees divided by sine of 70 degrees. And side A is 4.79. Therefore, now answer both questions in a word answer. Which tower was closest? Don't be tricked into saying A. It was Tower B. So Tower B is closest at 4.79 kilometers from the fire. And we're done. Triangulation in its simplest form is pretty much that. We know the distance between 2 points, and from each of those points we know a bearing to another third point that we're looking at and would like to find the distance.